right, folks, we're going to work through lesson 11 today. And lesson 11, the first activity here is talking about this graph. It says here's a graph that represents a proportional relationship. And again, we remember from last week that a proportional graph of a proportional relationship goes through 0, 0, goes through the origin, and is a nice line. Okay, so we know that's the graph of a proportional relationship. Here's what we notice: as the x value gets bigger, the y value also gets bigger by the same amount. So the first question says, invent a situation that could be represented by this graph. So what could you think of that as this gets bigger, this also gets bigger? Think of a proportional relationship that could be represented by that graph. Could be any little story, and write it down there, okay? Then it says label the axes with the quantities in your situation. So what does the x stand for? What does the y stand for? And then give the graph a title. And it says there's a point on the graph. What are its coordinates and what does it represent for your situation? So that point is right here. What are the coordinates of this point? Now I drew myself a table. The coordinates of that point, remember we go x first and then y. So in the x direction, we went over 16. In the y direction, if I scoot over here, we went up 12. I could ask you for that graph, what's the constant of proportionality? If x is 1, what would the y value be? And that would be that 12 divided by 16, which I believe is 0.75. Okay, so there's my constant of proportionality. If this was x, this would be 0.75x. My equation would be y equals 0.75x. Okay, so what's your little story that represents that graph? All right, and our next activity, activity 11.2, is about Tyler. Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. The point on the graph shows his arrival at the bumper cars. So let's see what units we have on our axes here. On the x-axis, that's time in seconds. And on the y-axis, we have distance from the ticket booth in meters. So that point 40, 50 means that after 40 seconds in the x direction, Tyler was 50 meters away from the ticket booth. So it says, what are the coordinates of the point tell us about that situation? It tells us something specific based on the axes, right? 40, 50 means that after 40 seconds, he was 50 meters away from the ticket booth. Question 2 asks us, the table representing Tyler's walk shows other values of time and distance. Continue the table and then plot the pairs of values on the grid. So here's our table. We know 40, 50. And we can find that constant of proportionality. We know that after 0 seconds he had gone 0 meters. How far had he gone after 1 second? So then what we're going to do is we're going to climb up, back up to the table, and we're going to graph those points. 0, 0 is right there. That's our origin. 20, 25 means we're going to go over 20 and up 25. Now if I go up 25, here's 20 and here's 30. 25 would be right dead in the center there. My next point would be 30, 37.5. So if I go over 30, up 37.5, well, let's see, that's not an exact corner point here. But if this is 30, this would be 35, and this would be 40, 37.5 would be halfway between that 35 and the 40, so it would be right there. And you can see those points as they start to, we start to put them on the graph, they fall in that nice straight line, right? After, let's see, what else do we have here? Oh, the question was after 1 second, how far was he? Well, let's see, 1 is not on our graph either, right? Over 1 second would be really close to the bottom of that graph, which we would expect it to be, 1 comma something, and we would draw that line down. But if we found that 1, that would come from that constant of proportionality. Divide that out. each of these divided, each of the y's divided by the x's, each of the distance divided by the time, except for this one, would give us that same number. Okay, so divide that out for me, and that would be that coordinate point. Question 3 says, what does the point 0, 0 mean in this situation? Well, that would mean after 0 seconds, Tyler has gone 0 meters, right? He hasn't started yet. How far away from the ticket booth was Tyler after 1 second? Well, what's that number? That's how far away he was after 1 second. And then 5 asks about the constant of proportionality. What does it tell you about Tyler's walk, and where do you see it on the graph? Okay, so answer those couple of questions. And then we're going to look at this question about seagulls. Seagulls they eat garbage. 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. It says plot a point that shows the number of seagulls and the amount of garbage they ate. So I'm going to go, I love me a good table, right? I'm going to make myself a table, noticing that in the x direction, we have the number of seagulls. So what I'm going to do is make x my number of seagulls. That's my x. And y will be the pounds of garbage. Delicious, fresh garbage for the seagulls. All right, so here's what we're told. 4 seagulls ate 10 pounds of garbage. 4 seagulls ate 10 pounds of garbage. And we want to put that point on the graph. So I would go over 4 and up 10. And because it tells us to assume a proportional relationship, we know that all the other points would lie on a nice straight line going through the origin. 0 seagulls ate 0 pounds of garbage. It says use a straight edge to draw a line through this point, through our 4, 10, and 0, 0. So a straight edge could be a ruler, or it could be the edge of your book, or it could be a piece of paper folded in half. Okay, and we'll draw a nice straight line through those points. Question 3 says plot the point 1, k on the line. Well, what is k? Let's see. K I find from dividing 10 divided by 4, which I think is 2.5. So now I can find that point on my graph. That would be over 1 and up 2.5, and I didn't draw that very well. I didn't use a straight line. I kind of freehanded it, but the idea is there, right? The question says, what is the value of k? Well, our k would be that 2.5. That's our constant of proportionality. What does that value of k tell you about this context? So as a sentence, in words, what this means is not just that I go over 1 and up 2.5. It means that when I have 1 seagull would eat 2.5 pounds of garbage. Garbage, delicious garbage, okay? So those numbers mean something to the graph. 2 seagulls would eat 5 pounds of garbage. 3 seagulls would eat 7.5 pounds of garbage. Those numbers all mean something in context. Let's just read through the lesson summary here and we'll be finished today. For the lesson, for the relationship in this table, y is proportional to x. We know that because when we divide each of those out, we get the same number. We can see that the 5/4 in the table is the value of k. It's the constant of proportionality because it's the value of y when x equals 1. So just a refresher there. We could also write the equation y equals 5/4 x to represent that relationship. Here's the graph of this relationship. So they put each of those points from that table, each of the points from the table up here went onto that graph. And it says if y represents the distance in feet that a snail crawls in x minutes, then the point 4, 5. So if this is time and this is distance, 4, 5 would mean that in 4 minutes, the snail can crawl 5 feet. Or if y represents the cups of yogurt and x represents the tablespoons or the teaspoons of cinnamon used in a fruit dip, then 4, 5 would tell us 4 teaspoons of cinnamon for 5 cups of yogurt to make that fruit dip. We want to remember we can find the constant of proportionality by looking at the graph and finding when x is 1, what's y? That's where our constant of proportionality is going to be located. In general, when y is proportional to x, the corresponding constant of proportionality is the y value when x is equal to 1. So we can, again, do that from the graph by looking over at the 1 and looking up to what the y value is. Or we could go back to our table and divide. All right, we're going to work on the practice problems for homework tonight, and have a great day, everybody. Bye-bye.